A chess engine is just a program. It has no intuition, no instincts, no feel for the game. It just looks at a board, runs some math, and picks a move. But to even get to that point, before any strategy, before any intelligence, you have to solve a deceptively hard problem. How do you teach a program what a chessboard even is? That's what Part 1 is all about. By the end, our engine won't be smart, but it will be alive. A computer doesn't see chess pieces. It sees numbers. So the first thing we need is a way to encode every piece, its type and its color, into a single integer. We use a simple bitwise trick. Every piece type gets a number. Pawns are 1, knights 2, all the way up to kings at 6. Colors are powers of 2. White is 8, black is 16. Combine them with a bitwise OR, and a black queen becomes 21. Pull them back apart with and you've got your piece and color back. One number, all the information. The whole board is just a 2D list of these. That's it. That's the board. Generating moves sounds simple. A knight moves in an L shape. Just check those 8 squares. A rook moves in straight lines. Check until you hit something. Easy enough. But chess has edge cases that will break a naive implementation. Castling is only legal if neither piece has moved, and the squares between them aren't under attack. En passant only exists for exactly one move after a pawn advances 2 squares. And any move that leaves your own king in check is illegal, even if it's otherwise valid. Get any of this wrong and your engine doesn't just play badly, it plays illegal chess. And then there's the deeper problem. Every position has roughly 30 legal moves. Each of those leads to another 30. By the time you're thinking 3 moves ahead, you're evaluating 27,000 positions. 5 moves ahead, 24 million. This is the problem the engine has to solve. Here it is, a board, a starting position, 20 legal moves, exactly as many as chess rules allow from the opening position. We pick one, make it, and the board updates. It's not thinking, it's not evaluating. It has no idea if e4 is a good move or a terrible one, but it knows it's a legal move. It knows the rules, it knows the board. That's the foundation, and it took real work to build correctly. If you want the full implementation, the piece encoding, the move class, the legal move filter, the verification technique we use to confirm it's right, it's all in the blog post linked below. The engine can move, but it can't think yet. Part 2 is where things get interesting. We're going to give PyMinMaximus a brain, the Minimax algorithm, alpha-beta pruning, and a basic evaluation function. It will stop moving randomly and start playing chess. The full write-up for Part 1 is on harlepenguin.com, link in the description. Everything we covered today is there in detail, with the complete source code. Subscribe so you don't miss Part 2. See you there.